Section 2.8, function, form, and literal equations. So first, to start off this section, we'll start by defining some words. An equation in x and y, so what that means is that there's x's and y's in your equation. So an equation in x and y is written in function form when the dependent variable y is isolated on one side of the equation. That's just a fancy way of saying when x and y are the variables in your equation, solve for y, or that just means get y by itself. Later in this section, we'll talk about literal equations. The definition of a literal equation is it's an equation that contains two or more variables. So this would be things like formulas and any equation that has more than one variable, so more than just an x and more than just a y. Our first example says rewrite the equation in function form. So remember, function form means get y by itself. So now looking at the equation, I see 9x minus 4y equals 8. Remember, my goal is to get this y right here by itself. If this said 9 minus 4y equals 8, my first step would be to subtract 9. But if this says 9x minus 4y equals 8, my first step will still be to subtract the 9x from both sides. 9x minus 9x is 0, so it cancels it from the left, and I'm left with negative 4y on the left-hand side. And then you might ask yourself, what's 8 minus 9x? How do I subtract something with an x with something that doesn't have an x? And the answer is you don't. 8 minus 9x is just 8 minus 9x. Typically, you guys see it, though, where the x is first. So I'm actually going to write this as 9x plus 8. I'm just going to flip it around, keeping the 9 negative and the 8 positive. If you kept it as 8 minus 9x, you will still get the same answer. That'll mean the same thing as if you didn't do it the way that I did it now, putting the x first. So here again, I'm trying to get y by itself. I'm going to divide now by negative 4. I'm not just going to divide the negative 9x by negative 4, and I'm not just going to divide the 8 by the negative 4. I'm going to divide everything by negative 4. So these 4's are going to cancel, leaving me with y on the left, and I'm going to take negative 9 divided by negative 4 and 8 divided by negative 4. Negative 9 divided by negative 4 is positive, I'm just going to keep it as a fraction, 9 over 4, and then I have the x. And then 8 divided by negative 4 is negative 2, so I'm going to say minus 2. So notice I kept the negative 9 over negative 4 as a fraction, but since a negative divided by negative is a positive, I kept it as 9 over 4, put the x back on it, and then 8 divided by negative 4 was negative 2. So my function form answer for this equation was y equals 9/4 x minus 2. Let's try another one. Rewrite the equation in function form. So this time we have 6 minus y equals 17x. Again, function form means to get y by itself. So if this just said 6 minus y equals 17, my first step would be to subtract 6. But it says 6 minus y equals 17x. But again, my first step would still be to subtract 6. The 6 is positive, so that's why I'm subtracting it. It was the y that was negative, so I still have negative y equals, now remember, 17x minus 6, I can't subtract things that are not alike. So 17x minus 6 is just 17x minus 6. Our next step is to remember there's technically a negative 1 in front of that y. So to get y by itself, I need to divide by negative 1. But just like in the last example, I'm not just going to divide 17 by negative 1. I'm also going to divide negative 6 by the negative 1. I have to divide that entire right side by negative 1. So 17x divided by negative 1 would be negative 17x. And negative 6 divided by negative 1 would be positive 6. So my function form answer in this one would be y equals negative 17x plus 6. And let's look at one more example. Number 3, rewrite the equation in function form. Remember, function form means to get the y by itself. So our equation is 7y minus 9x equals 21. If it said 7y minus 9 equals 21, I would add the 9 first. So in this case, I'm going to add the 9x first. To add 9x to 21, I'm just going to keep it as 21 plus 9x, but here again, I'm going to flip it around so that the 9x comes first. So 9x plus 21. Remember, the 9 was positive, and so was the 21, so I'm going to keep it as such. And to then get y by itself, I would divide by 7. Remember, I'm going to divide the entire right side by 7, so I'm going to take the 9 divided by 7 and the 21 divided by 7. So 9 divided by 7 is 9/7, and I still have that x. It was 9x divided by 7, so 9/7 x. And then 21 divided by 7 is 3. So my function form of that original equation is y equals 9/7 x plus 3. And one more, example number 4, rewrite the equation in function form. 4 plus 6y equals 12x minus 2. So here again, function form means to get y by itself. So I'm trying to get this y by itself. So the first thing I want to get rid of is that 4. So I'm going to subtract 4. On the right side, I need to decide, am I going to subtract 4 from the 12x or from the negative 2? In this case, I'm going to subtract it from the negative 2 since it is like terms with the negative 2. So subtract negative 4. Notice I'm writing it underneath the negative 2, so I visually see that I'm taking it away from the negative 2 and not the 12x. So I have the 4's cancel, 6y equals 12x, and then negative 2 minus 4 is negative 6. I would then divide both sides by 6. Remember, I'm not just going to divide the 12x by 6, but also the negative 6 by 6. So I would end up with y equals 12x divided by 6 would be 2x, since 12 divided by 6 is 2, and negative 6 divided by positive 6 is negative 1. So the function form of that equation is y equals 2x minus 1. Example number 5 gets us into the literal equation. So remember, a literal equation is an equation that contains 2 or more variables. So yes, what we were just working with when we were writing equations in function form, those were technically literal equations, but when I think of a literal equation, I really just think of formulas. And what I'm doing with those is things like in number 5 here. The formula for the volume of a rectangular prism is V equals L times W times H, and they want us to solve the formula for L. So the first thing I'm going to do is just write it down. So V equals L times W times H. Notice I'm writing my L as a cursive letter, so I'm not confusing it with a 1 or a 7. So it wants us to solve for L. So right now, L is being multiplied by the W and the H. So to get rid of multiplication, I have to divide. So I'm going to divide both sides by WH. I'm going to do it all in one step. So WH divided by WH is 1, so that's going to cancel these, leaving me with L on the right side. And then V divided by WH is just simply V over WH. Now I know some of you might end up being a little iffy about leaving the L in what you were supposed to solve for on the right side. So if it makes you feel better, go ahead and just flip it around and say L equals V over WH. They both mean the same thing, but again, a lot of you just like it so the variable that you solve for is on the left, so just go ahead and flip it around. But when you flip it around, make sure you keep it exactly as it was on the left-hand side as V over WH when you flipped it around. Let's look at another example, number 6. The formula for the interest is I equals P times R times T. You should recognize this from when we did formulas in the last chapter. So using this formula for interest, they want us to solve it for P. So again, the first thing I'm going to do is write down the equation. I equals P times R times T. And they want us to solve for P. So I'm trying to get that variable by itself. So just like the last problem, P is being multiplied by the R and the T. So I'm going to divide both sides by RT. So these are going to cancel, leaving me with P on the right. And I divided by RT is just simply I over RT. Again, if you want, you can just flip it around so that P is on the left side. Just again, make sure if you're doing that, you're not changing anything. You're keeping it as exactly as it was on the left-hand side. So P equals I over R times T. Example 7 is our last example and also our hardest example. The formula for the area of a trapezoid is A equals 1/2 times B1 plus B2 times height. Solve the formula for B2. This formula should be familiar from last chapter, but this time we're trying to isolate the B2. Okay, so the first thing we're going to do is write down the equation so I know what I'm working with. And I want to get rid of the things that are all around the B2. We've learned in this chapter to get rid of 1/2, anytime you want to get rid of a fraction, is to multiply by the denominator. So I'm going to multiply by 2 so I can get rid of that 1/2. So these 2's are going to cancel, but if I multiply by 2 on the right, I also need to multiply by 2 on the left. So 2 times a is 2a. When I multiplied the 2 times the 1/2, the 2's again canceled, leaving me with this 1. But is there any purpose to distributing a 1 to a parenthesis? There's not. So I'm just going to leave it as parentheses b1 plus b2, and then times the h. So here again, I am trying to get the b2 by itself. Right now, this entire parenthesis is being multiplied by h. So let's get rid of multiplying by h. To get rid of multiplying by h, I divide by h. So those are going to cancel, and I would have 2a over h equals b1 plus b2. I took the parentheses away this time because there was no need for them anymore. So scrolling down here so we have more room, now I have 2a over h equals b1 plus b2. Remember, I'm trying to get b2 by itself. So to get it by itself, I would now subtract the b1. So 2a over h minus b1 is just simply that, 2a over h minus b1 equals b2. So our final answer, if you want to flip it around, b2, so base 2 in your trapezoid, could be found by taking 2 times a over h and subtracting b1 from it. That's it for this section. Make sure you write down any questions that you have that we need to cover in class, and then we'll see you then.